Hi everyone. I'm sorry I've been gone for the last couple days. So since yesterday I kind of left you on your own to do chapter 10.4, what I wanted to do today was try to at least sort of be with you and working through some of those problems so that you can kind of verify what you've learned on your own from yesterday. So in 10.4, what we're doing is solving polynomials in factored form. The objectives that we're looking for here are to, first of all, recognize what factors are in factored form and to recognize factor form in general. So I'm sure you've read about that some in 10.4. And the other objective is to use the zero product property. So once again, I'm sure you've seen that. Whether or not you've written that in your notes, now is going to be the time to do that. And then 3, review that solutions and x-intercepts are closely related. So we've done that in the past. We've taken a test on that. So we're just confirming that, and we're just now finding more ways on how to find a solution or an x-intercept to some sort of given equation. This is what I do want you to write down in your notes. To solve a quadratic or a polynomial means you need to find the solutions. And just remember, solutions are the x values of the x-intercepts. So please do write that down in your notes. I've had you write this down a lot, but you're going to write it again because we haven't written it down in our notes in chapter 10 yet. Chapter 9, you probably wrote this down at least a few times. Okay, so please do write this piece down. So when we're solving our equations, we're finding solutions, and I mean, when I have asked in the past, how do you solve this? And people will say, well, find the answer. It's true, you need to find the answer, and answers we specifically call solutions. Solutions are the x values of the x-intercepts. So you really need to be able to find x-intercepts. Alright, so in the past, please do write this example down. Find the x-intercepts and solutions of the following quadratic. So I've given you this. Remember, in the past, what we have done is we've graphed this and found the x-solutions, or the x-intercepts, I'm sorry. But otherwise, the other option that we have is to use the quadratic formula. The quadratic formula gives you solutions or gives you the x-intercepts. So I'm going to go ahead and say we're going to use the quadratic formula. Use quadratic formula. Alright, and I will just write that out for you. X equals opposite b plus minus square root b squared minus 4ac all over 2a. Okay, so remember, that's the quadratic formula. That's our little jingle for it, and that's what we use to find solutions of a quadratic. First things first though, get in standard form. You need your quadratic in standard form. You need this in standard form. So in other words, you need everything on one side of the equal sign. You see this -4 over here hanging out? Can't be there anymore. So I'm going to add a 4 to both sides. What I'm going to get is x squared plus 5x plus 4, because I can't add 4 to 5x. They're not like terms. They don't have identical variable parts. I can't add 4 to x squared to have something like 4x squared. It's its own little thing. It's unlike any of the other terms there, so I mean, all I can do is write it like this. And then we're trying to figure out when this is equal to 0. Okay, so in other words, we're trying to find the x values that's going to have a y equal to 0. So this is when we would have gone through and said, well, a is 1, b is 5, and c is 4. Okay, just looking at, first of all, there's technically a 1 there. Then we could go ahead and plug that into our quadratic formula. So here I go, x equals So when we go and solve for solutions using the quadratic formula, what I always advise is to go to what's underneath the radical, simplify it first. Okay, so I'm going to get -b plus minus, and then I'm going to go ahead and just type in your calculator if you need to. 5 squared minus 4 times 1 times 4. Just type that into your calculator. What you're going to get is 25 here minus 16. You're going to get 9 all over 2a, which was, when I simplify that, it's 2. So x is equal to -5 plus minus. Now here I'm looking at the square root of 9. That is something that we can simplify. Remember, we have this list of perfect squares. We had 4, 9, 16, 25, 36. We also had one in there. Sorry, I skipped one. So here, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. These are all what we call perfect squares because they are a result of a number being squared. Okay, so here, remember that radical undoes that squaring effect. It undoes perfect squares. So if you have 9 here, you could relook at 9 as the square root of 3 squared, and that radical and that power of 2 cancel each other out. So I have 3. Try it in your calculator. If you take the square root of 9, you get 3 all over 2. So this results in 5 plus 3 over 2 and negative 5 minus 3 over 2. Our answers, or our solutions, are negative 5 plus 3 would be negative 2 divided by 2, negative 1, and x also equals this on top. If you do that, it's going to be negative 8 divided by 2, it's going to be negative 4. Our results, or our solutions, are x equals negative 1 and x equals negative 4. So here are our solutions. Okay, and then the x-intercepts, remember how closely related they are? I'm just going to call them x-ints. Remember, those are just taking the solutions that you found and putting in the form of a plot point on our graph. Okay, so there we have it. So find the x-intercepts and solutions. I hope this serves as a good review of what we've done in the past to find the solutions and the x-intercepts as a quadratic formula. And I do just want to go ahead and show you. I want to show you what this graph looks like. So I'm going to take this equation, x squared plus 5x plus 4, and I've gone to, where is it? Up here. I've gone to an online graphing calculator, and I've typed in that x squared plus 5 times x plus 4, and I'm going to graph it. Okay, there it is. So what I want you to notice is right here we have an x-intercept. Notice that's that negative 4 comma 0 that we found. Right here, this point as well is that negative 1 comma 0. So we found those two x-intercepts by using the quadratic formula, or in other words, we found the solutions, the x values of the x-intercepts, negative 4 and negative 1. Okay, that was our review. So now we're going to get into the new stuff, and what I'm going to be introducing to you is a new form. It's called factored form. And factored form, it's this versus our old form, which was standard form. So standard form was the old way. And that was when we would be adding terms that were just multipliers with some sort of variable part. So we would have y equals, for a quadratic, for example, something like this. And we also typically had it that it was in standard form, so that the degrees, or the exponents on each one of these terms being added together, the degrees would be in descending order. So you would start with your highest degree and then slowly go down. Factored form is going to be slightly different, well, actually greatly different. What it's doing is it's taking a bunch of different factors and multiplying them. So you're going to have these chunks, or binomials. Here we have binomials because there's two terms in here separated by a subtraction. But keep in mind, this could go on forever. I could have, this would be another factor being multiplied, or another binomial, and dot dot dot. You could multiply as many pieces together as you wanted to. So factored form is when you're going to be taking polynomials of sorts and multiplying them together. One of your objectives was to be able to find out what are the factors in factored form. Are you able to identify them? So if I gave you something like this, and I said identify the factors, so please do write this example down. So if you needed to identify the factors, or the pieces that were being multiplied together, there are 3 factors here. There is a 2, so your answer here, identify the factors, you have 2. You have x plus 4, that's one binomial that's being multiplied to everything, and x minus 5. Okay, So that's factored form, and that's being able to identify what are your factors within that factored form. Another thing that you might have looked into yesterday while you were reading all this chapter and trying to learn it on your own was the zero product property. And what that states is if multiplying factors, so please do write this down. If multiplying factors, and this is the zero product property, so I'm just defining what that is from your book, please write it down. If multiplying factors and the products or the result is equal to 0, then one or more of those factors had to be 0. So example of this, if let's say 3 times x is equal to 0. Okay, here are my two factors, 3 times x. Okay, so I have two factors, two things that are being multiplied to each other, two pieces that are being multiplied. Then one of these factors had to be 0. 3 can't be 0, so what the zero product property is saying, then x had to be 0. Here's another example. If x minus 1 times x plus 2 is equal to 0, then what we're saying is one of these factors or more is going to be equal to 0. So if you look at this, x minus 1, that's possibly equal to 0, or x plus 2 is equal to 0. Okay? So this is one of those cases where you would have to solve for each one of these. X is equal to 1. If you go ahead and add 1 to both sides to solve and get x by itself. X is equal to negative 2 because you would subtract 2 from both sides. X equals 1 would get you this equation equaling 0. X equals negative 2 would get this equation equaling 0. And that is how we use the zero product property to solve for these equations, because when you have factors that are equaling to 0, what you can do is set each one of your factors equal to 0 and then solve for them. So I'm going to do more examples. So I'm going to do number 2, and it's straight from your homework, are 1 and negative 4 solutions of, and then they give you this factored form equaling 0. So they give you a polynomial that's in factored form equaling 0, and they're asking, are these solutions? So let's go ahead and look. Well, the zero product property states this, that if these multipliers are equal to 0, then this first factor and this factor, they would have to, one and or both would have to equal 0. So let's solve it. Let's subtract 1 from both sides. X is equal to negative 1, and in this case, when you add 4 to both sides, x is equal to 4. So when you're looking at these are the solutions. If you were to plug in negative 1 into this, negative 1 plus 1 times x times negative 1, if you were to plug that in to your equation, so let's check our answer. If we plugged in negative 1 into this equation, we get negative 1 plus 1, which is 0, times negative 1 minus 4, negative 5, is equal to, does it equal 0? Well, it sure does, because we set that factor equal to 0 and solve for it. Okay, let's check this solution. So let's plug that in. I'm going to plug in 4 for my x, 4 plus 1, and then I have 4 minus 4 equals 0. I just plugged in 4 for my x's. I substituted it in. I get 5 times here. When you do this parentheses, you're going to get 0. And yeah, it does equal 0. These ones up here, they were not solutions. The solutions that I have are negative 1 and 4. I'm also going to do number 22 with you. It says use the zero product property to solve the equation. So I want to remind you that this is, when we have w minus 17 whole quantity squared like that, we can rewrite this as w minus 17 times w minus 17, and then that's equal to 0. So in this case, what we're going to be looking at is setting each one of these factors equal to 0. So minus 17 is equal to 0. Whoops, I don't know, sometimes it does that, sorry. And w minus 17 equal to 0. So I've identified my two factors. Sometimes you have more than that, so be cautious of that. But now I'm going to solve for that w. I get w is equal to 17. Okay, and then w is equal to 17. It's okay if you get the same exact answer, but what I'm just going to have you do is write it like that. So for number 22, your answer is kind of like a double answer. You have w is equal to 17 and w is equal to 17. So here is the assignment that I'm going to be giving you again. Since I'm not there, I don't know, but hopefully you have enough time to be going through some more of these, and I've kind of taken problems from each one of these sets and solve those types of problems. I do want you to be aware that I did change this assignment. Yesterday up here after 46 I had that you should do 53 and 54. I've changed that, so hopefully you guys didn't do 53 and 54 yet. Please do 48 and 50 instead of those two. So I'll be coming around. If anyone did that, I can possibly give some extra points there or something if you ended up doing 53 and 54. But 48 and 50 is what I do want, and I would ask you please look on page 599. So this is using your free resources, and look at example 4, because it's going to be, you're going to want to graph these, and it shows you exactly how to do it. If you know the x-intercepts, that's what you're going to do. You're going to find the x-intercepts, and then you're going to go back to finding the vertex. And I have confidence, and I believe you'll surprise yourself that you're going to be knowing exactly what example 4 is talking about. I do want to look at 44 and 46 really quickly, or 44 through 46. 44 through 46, what it has are A, B, and C. So A gives you y is equal to x plus 2 times x minus 4. They give you the equation for part B, y equals x minus 2 times x plus 4. And then they give you C, y is equal to, I'm going to run out of room, x plus 4 times x plus 2. And what they ask you to do is for 44 through 46, they have graphs. So I'm going to quickly sketch 44 on here. You have it in your book, so you wouldn't have to do this. They give you a graph that looks like this. Alright, and what you need to do is match for 44 which one of these represent the equation that's graphed. So the key thing that I want you to note is that you know that these x-intercepts are going to be fitting into that form y equals x minus r sub 1 comma x minus r sub 2. You know that it looks something like that. So if you go back up, and then there is sometimes an a out here, there could be like a 2 with 3. All of these have just 1s out as that a in factored form. But if you can go up to these and figure out, alright, what are my x values of my x-intercepts? Or in other words, what are the solutions when these are all equal to 0? Let's solve for this. My solutions would be when x plus 2 is equal to 0, and when x minus 4 is equal to 0. Okay, so I'm going to be using that zero product property to solve for my solutions minus 2. X equals negative 2. This one is going to be x is equal to 4. My solutions, or the x values of the x-intercepts, are negative 2 and 4. Is 44 going to match up with A? No, because what we're looking at here, the x values of my x-intercepts are negative 4 and negative 2. I'm going to go ahead and say it is C, but you're going to want to figure out why. Alright, so 45 and 46 are just like that. You actually have to just be looking at the graph and trying to match it up with which equation it goes with.